Now, when we have a leading coefficient that's not a greatest common factor that we can factor out, then we're going to have to do what we did in our first example, and we have to factor by grouping. The difference is that instead of using the C value, we're using the value of A times C. So in this case, we want to get a product of 12 times negative 2, which is negative 24, but we still want that sum of the B value, negative 5. So negative 24 divided by x, we look at our table, we want a sum of 5. That's going to be 8 and negative 3. So, I'm sorry, negative 8 and a positive 3, negative 5. So we're going to do factor by grouping, and we're going to split into negative 8r and 3r. We still have 12r squared and minus 2. Factor by grouping. Since we already have 3r minus 2, we just need to factor out a 1, leaving us with our 2 factors. So there's not really a shortcut with this one. We still have to kind of work through because we need to make sure we have the proper leading coefficients. B, A times C equals 6, and B is 7. So a product of 6 and a sum of 7 is going to be 6 and 1. So we can rewrite this as 3x squared plus 6x plus x plus 2. So our 2 factors, x plus 2 and 3x plus 1. Same logic applies even if we have more variables. We want 18 times negative 12, which gives us negative 216. And our B value for our sum is negative 19. So we take a look at our table, and 8 and negative 27 give us our values. 18m squared minus 27mx plus 8mx minus 12x squared. That's a good point to mention that the order of these two terms doesn't really matter. Usually you can put it in either order and still get your GCF. But if for some reason you're having trouble, try switching the order of the two terms and see if that helps. Factor by grouping. 9m, 2m minus 3x, plus 4x, 2m minus 3x, 9m plus 4x, 2m minus 3x. Again, we want a product of negative 36, but a sum of 16. That's going to give us the values of negative 2 and 18. Now for this, instead, if you wanted to factor out a positive 3x instead of a negative 3x, you would end up with an equivalent expression of that. Now in this one, note that we actually have a GCF. We have a GCF of 8y, which leaves us with a much simpler trinomial. Where this time we only need a product of negative 4 and a sum of 3. So again, don't forget to check for greatest common factors. If you miss it, then it's not considered simplified or factored completely. The numbers that give us our product and sum are -4 and 1. Notice how the greatest common factor is following along because it is included as part of the solution. And there's our 3 factors. Now here we can use a method called factor by grouping, or sorry, factor by substitution. Makes it a little bit easier to deal with when we have the binomials. The idea is still the same. We're doing product and sum. So we'll be using the numbers -3 and 8. But instead of using x plus 3, we're going to let x plus 3 equal some other variable like y. That lets us rewrite the equation in a much more manageable process so that we can factor it without having to deal with all the extra parentheses. And once it's factored, we can go ahead and substitute x plus 3 back in for both y's. Apply a little distributive property and combining like terms. Again, combining like terms. And we get our fully factored polynomial. Here we have a trinomial that's quadratic in form, but it's not a quadratic. But we can still factor using our grouping. So we want a product of -120, but a sum of 7. That's the numbers 15 and -8. We just need to pay attention when we're splitting to make sure we have 15y squared minus 8y squared. We want to keep those exponents in the proper place. So our GCF for the first two is 3y squared, leaving us with 2y squared plus 5. And in order to end with a 2y squared plus 5, we need to factor out a -4, 3y squared minus 4, and 2y squared plus 5.